will be going to the second part of this presentation for a case study of building information modeling, the Commercial Boulevard we have seen before. In this part, we are going to talk about how we will model and what we are going to do with the data that is required in order to reach to the desired level of detail and development on our models. As we said, these models represent elements that are linearly dependent. And as linearly dependent are elements that are constructed out of a 3D alignment evolving in space and sections that are being dependent in different positions on this alignment. As we are saying here, the road and linearly dependent elements have been modeled utilizing Bentley's solution, Power in Roads V8i. The first step in order to create such elements is to create the horizontal geometry from the setting out plans by using the road center line, sometimes denoted in the drawings as CL. And you can see it here as a red element, which is the horizontal alignment. After we model the horizontal alignment as a line in a 2D space, we have to go and model or create, update points of this line with the elevations such as the ones that we have in our design. As you can see it here, the vertical elevation from a drawing, the vertical alignment from the drawings, it's coming in these elements, and the numerical data required are down here, usually in the form of a table that is dependent by the length of this element. By combining these two elements, we arrive on the 3D alignment for the road corridor, and we're going to take the next steps from there. As you can see here, we have the 3D alignment evolving in space, and next to it, in the program, we always have the vertical alignment, as we said in the previous slide. Now, since we have these alignments, what are we going to do with them? We have to create in a library of sorts some templates that will denote the different sections from chain edge to chain edge on this project. And this is generic for each linearly dependent project. What we have to do is create in an environment that will allow us to save some different templates and be able to assign them in different chain edges of the newly created 3D alignment. As you can see here, we have in our program a library with our templates, and each time we will have an active one in order to be able to assign it in different chain edges. Final step is to combine these two together. From chain edge X to chain edge X plus A, assign one template, from X plus A to X plus B, another one, and so on and so forth. As a result, we're going to get 3D models that have all these layered and linearly dependent geometries, one by one, and even very, very complex ones, such as tunnels, such as elements within the tunnels, bridges, and structures that are not easily created through conventional modeling. Now, leaving the civil elements behind, we have to discuss about the MEP elements that go along the road or depend from this linear development of the road. In this particular project, there have been developed an EcoSim VBA tool that allowed us to model quickly and reliably, without the possibility of any error, with automation as well, the 3D elements of the networks of the irrigation, water processes, and electrical utilities as well. Additionally, it could provide tags or other metadata that is required for quantification and sequencing for these elements. So as you can see here, this is an in-house modeling toolbox that could go easily and create this 2.85 kilometers network of gravity stormwater network which you see here in a 3D view, and over here in a side view, and in a detail over here. Moving on, the things that we could do with these toolboxes is not just modeling, as we said. They are additional elements. It's not just of pipes, but manholes, gullies, concrete encasements, such as you can see here. And additionally, we could enhance it with data in these elements, such as the ones that exist on the design drawings we had in our project. The data, as we can understand, for such networks are a big list of data that need certain fields to be accommodated into. And this has happened for the manholes, as you can see here, per the IFC project drawings. We had our invert level, we had our cover level, the depth of each one, easting and northing its location for the cover, and the manhole type for the material takeoff. A lot of concepts. Now you can see the same thing for the piping data, the different element properties that we had per element, which was the pipe diameter, the average pipe depth, the pipe material, the ID of the pipe, the thickness, and the part utilized for the library for quantification reasons as the gravity stormwater system. You can see some general information now for another network aside the stormwater, the irrigation network, which is pressurized in contrast with the gravity network of stormwater. Additional elements over here, pipes, fittings, chambers, valve chambers, wash-out chambers, and concrete encasements whenever we're going under a road and we need that extra strength. And moreover, the data, as we saw in the previous, all these elements were created by these automation tools by a checked process that didn't allow, from automation, any mistakes. Moving on, all information fed into the models when quantified. The civil models, structural elements, waterproofing elements, and the MEP elements for the networks. All these provide the quantity takeoffs through the utilization of the platform of Bentley EcoSim SS5 revision for V8i. In an automated application which was in-house developed, these quantity takeoffs deliver the bill of quantities, which is the result, as you can see here, additionally from the model that fed the database that we had to develop in order to satisfy the client's requirements. So you see some in an Excel view, which still is a database, all this information, but what we had to deliver was in an SQL database. We will talk about it in 2 minutes. Now, these databases are very, very big tables, actually. And as very big tables, they require something more than simple Excel in order to be manipulated or create something new out of them as per the requirements of the client each time. We utilize the platform that has been developed again in-house, and it's for many years a leading platform in the space of automation and project controls, quantity monitoring, QA/QC checks. It's called C3D, and it's a novelty created by Consolidated Contractors Company, which did what? It did a number of operations at the same time. It verified that the information we had on our models were consistent and correct against the models, and vice versa. It did numerical QA/QC checks, such as the ones that you can see here. Zero quantity elements, same BOQ codes, different BOQ descriptions. All these things were taken care in an SQL environment within C3D platform. Again, I say developed by a Consolidated Contractors Company. The client requested the database, but any database has to be in a certain format. And client, knowing what he wanted, he asked for a specific format, which meant that we could not have something unorganized, but something that has to be organized with location tag sets, with a lot of different levels of information per element, and additionally documentation that is developed from scratch from the BIM team of the project. Moving on and leaving the data and modeling behind, after all this has been completed, we reach to the final stage, which is the as-built phase. In the as-built phase, we have to implement two different checks in order to be able to verify that what we have done is correct as per our drawings, and what we provide our client will be useful in order to operate this element, so this project. So we have the geometrical consistency that is being verified by a technology utilized for the last 10 to 15 years, which is laser scanning, and the data, as we said before, with the checks from C3D. Coming to the laser scanning processes, you can see that we didn't have a lot of details because it's a new process on our project, but there was a need for monthly deliverables. So we had some monthly deliverables of point clouds for presentations, for reasons to get the excavation progress, for example, or the concrete progress. And as we found out in our project that we could utilize the point clouds for the excavation and earthworks and backfilling progress, as you saw in the previous presentation part. And as we said, the laser scanned point clouds are utilized primarily to check the as-built, that what we have done on the site is verified in the correct location with the correct dimensions as the elements that we have in our model coming from our shop drawings. You can see here, for example, one element, one scan that we have, which is a combination of a lot of scans of around 500 linear meters of the road on a corridor of 200 meters at this direction. In order to see some of the geometry checks, presentations and different layouts were created to be sent to the client, and for our internal revisions, as you can see over here, you can see the laser scans for one zone of the project as a general view. Matter of fact, you have to see that this is the start of the project. The chain edge, let's call it 0, although it's 0 plus 80 meters, till the chain edge 1,100. So we're talking about 1 kilometer of corridor scanned for our project. What you can see here, for example, is a junction. You can see it, that it is superimposed with the models of the utilities on the laser scan, and you can see buildings that have been built around our project. Let's go a little bit deeper. Now we are on some layouts in chain edge from 80 to 350 for our utilities. It's easily discernible that here is our as-built situation from the laser scan, and within the casements or different positions of the projects, we can see model coinciding with the laser scanning, which means what? That our construction is correct and our modeling is correct as well. On another layout, we can see capturing the changes that happened on site, which was not reported for X or Y reasons. Over here, in the design, there was a manhole that, due to problems in the construction, has been moved over here. The model is going to be adjusted accordingly, and everything is well since we have the consent of our client. Now let's go to another example, which is going to be our final example for laser scanning. We need to explain that this is our tunnel. This is one part of the road tunnel. This is the other part of the road tunnel. And this is the light rail trail tunnel. On a section view, we can easily see that the points of the point cloud coincide with the model. And we can easily see as well that although on one side we have the top slab scaffolding obstructing the view of the points that are of interest to us, on the other side we don't have it, or it means that they are removed. So we utilized specialized software in order to clean out our point cloud, to keep only the elements that we want in order to do our verification checks and deliver it to our client. Thank you very much for your attention. This was a presentation for a case study at Commercial Boulevard.